Hey everyone, and welcome. Today we're getting into an explainer of Lecture 21 by Skip Uni. And honestly, we are unpacking a massive, fundamental building block for anyone jumping into code. If you're starting your journey with C++ programming for beginners, this is absolutely a lesson you need to master. We're going to be looking closely at the if-else statement in C++, breaking down exactly how decision-making in C++ works, and really getting a solid grip on control flow statements in C++. Basically, it's the core logic that makes software actually smart. Okay, let's dive into this. Here is our roadmap for today. First up, decisions in C++, followed by the simple if statement, then multiple independent ifs, the if-else statement, and finally a quick summary and next steps. Section 1. Decisions in C++, control flow logic. So standard programs just run top to bottom sequentially, right? Which is fine, but that means they can't actually make smart decisions on the fly. To fix that limitation, we bring in conditional logic. Skip Uni uses a brilliantly relatable analogy here. Think back to your childhood. If your marks are greater than 80%, you get a Ranger bicycle, else you don't. Or a bit more practical in the adult world. If your age is greater than 18, you are eligible for a driving license, else you aren't. It just perfectly grounds the programming logic in these everyday binary concepts. You're simply giving the computer a choice based on a specific condition. Now, depending on what we actually need our software to do, C++ gives us a whole toolbox for handling these conditions. We've got the simple if, where the else part is completely optional. We have multiple ifs acting sequentially and independently. We have the standard if-else for mutually exclusive choices. And later on, we can get into nested ifs, which are conditions deep inside other conditions, and else if for checking a sequence of multiple conditions. Today, we're focusing entirely on those first three to get your foundation rock solid. Section 2. The simple if statement. True or false only. You know, what's really interesting here is that computers don't deal in maybe or sort of. These statements strictly evaluate to a Boolean true or false. Here is the exact machine flow of how C++ processes a simple if statement. First, it evaluates the condition inside the parentheses to see if it's true or false. Second, if it is true, it enters the code block. Third, it executes the internal statement, like printing a message. And finally, it safely exits the block. Honestly, this really dispels the intimidation of coding syntax when you realize the computer is literally just following these four basic steps. Let's see this in action. Skip Uni gives us a great integer example. Imagine we declare our variable num and set it equal to 10. Our condition asks, is 10 greater than 0? Well, yes, that obviously evaluates to true. So the program successfully enters the block and prints the words positive number. But let's contrast this. What if we set num to -1? The program asks, is -1 greater than 0? That is absolutely false. And because it's false, the program completely skips the internal block. It ignores whatever is inside and just moves straight forward. Section 3. Multiple independent ifs, sequential checks. So, what exactly happens when we chain several if statements together without any else safety nets? Well, the crucial point is that the program acts relentlessly here. It evaluates every single condition independently, completely regardless of what happened on the line right before it. Skip Uni illustrates this perfectly. With a divisibility test, say you write 3 separate if statements, asking, is the number divisible by 2, by 3, by 4? If your input number is 2, the program checks the first condition, sees it's true, and prints that it's divisible by 2. But it doesn't stop. It pointlessly proceeds to check the condition for 3, which is false, and then 4, which is false. It executes every single check. Section 4. The if-else statement, exclusive paths. Now, bringing in mutually exclusive branching. Keep in mind, an else statement cannot exist independently. It has to be attached to a preceding if. Think of this as a strict binary fork in the road where the control flow is forced to choose one path or the other. If the initial condition is true, the if block executes, and the program instantly exits the structure. But if that condition is false, the program skips all the intermediate lines and jumps directly over to the else block. To test this logic out, Skip Uni introduces a modulo arithmetic example. Modulo, which is represented by the % in C++, simply gives us the remainder of a division. So checking if num %2 equals 0 is essentially asking, if I divide this number by 2, is the remainder 0? This is the absolute classic way programmers check for even and odd numbers. Let's throw the number 3 into this. 3 divided by 2 leaves a remainder of 1. Does 1 equal 0? No way. That evaluates to false. Therefore, the control flow completely ignores the if block, jumps directly down to our else block, and prints odd number. Now let's try 4. 4 divided by 2 gives a remainder of exactly 0. 0 does equal 0, which means it evaluates to true. The program jumps right into the if block, prints even number, and then immediately exits the entire structure, skipping the else block entirely. Section 5. Summary and next steps. Synthesize knowledge. All right, we have covered some fantastic ground today. Let's synthesize the most important takeaways. The core difference between the two main structures we covered is this. Multiple independent if statements will relentlessly check every single condition sequentially. But the if-else statement, it acts as a strict fork, executing only one valid path and ignoring the rest. Skip Uni leaves us with this highly practical advice. Common programming use cases for this include finding the greatest of two numbers or checking advanced divisibility. And that makes total sense. Understanding these basic building blocks really matters for writing efficient, real-world software. And hey, if you're wondering how to handle more complex scenarios, don't worry. This foundation will be perfectly built upon in the upcoming lecture, where we'll take a deep dive into else-if chains and nested if statements. Before you go, Skip Uni has an interactive challenge for you. Think back to our multiple independent if statements checking divisibility by 2, 3, and 4. If the input number is exactly 4, what will the exact output be when the code runs? Take a second, think actively about how that logic flows step by step, and I will catch you in the next explainer.